Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be starting Chapter 1, which is Sequences and Series. So specifically we're going to look at arithmetic sequences today. So an arithmetic sequence is a pattern of numbers where a constant value is added to create the next term. So in example 1, we've got 3, 5, 7. Well, the dots represent basically all of the numbers in between. And so in these arithmetic sequences, they have what's called a common difference, and that's represented by D. And that is basically how you get to the next number. So in this case, we would be adding 2. One important thing to note is every time you are adding a number, no matter what. So you could, if it looks like you're subtracting, well, technically what you're doing is you're adding a negative. So in this next example, well, we're going down by 3, so that means we are adding -3 in each of our sequences. So our next number in that example 2 would be 1, then we'd have -2, so on and so forth, all the way to -290. In this one, we've got 1/6, then 2/6, then 3/6. Well, looking at the pattern, you can see that your common difference is 1/6. However, if you can't just look at it and see what the pattern is, in order to figure out what your common difference is, you go term 2 minus term 1, and you also want to check a second one, so maybe term 3 minus term 2. I mean, really, you could also do term 977 minus term 976. So in this, that can help you figure out what the common difference is, because it has to happen in every single interval. So if it had added by 1/6 in the first one, but then had added by 1/3, well, then that wouldn't be an arithmetic sequence. So if we wanted to check, we could say 2/6 minus 1/6, well, that is 1/6. And just to double check, we would say 3/6 minus 2/6, well, that is also 1/6. Therefore, our common difference is 1/6. So our next one, 2, 5, 8, 11, so on and so forth until 32. This is an example of an arithmetic sequence. If I was to fill it out, we would then have 14, 17, 20, we'd then have 23, 26, 29, and then we would have our 32, which was our end term. So determine the following. Well, T1, that represents our first term. Well, the first term is always whatever you see at the start of the sequence. So in this case, T1 is equal to 2. Our common difference, again, that's what you add every time. So if you wanted to check and you weren't sure, you couldn't tell that it was going up by 3, because sometimes that's not always nice perfect numbers. Term 2 minus term 1 is 3, and maybe a quick check of term 3 minus term 2. Well, that's also 3. So then therefore we probably have an arithmetic sequence. We've then got our second term. So in this case, term 2 would be 5. Number of terms n. So number of terms is how many you have in your sequence. So if I look, and in this case we've got a small enough number so we can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so in this case, the number of terms, that sort of was like those dashed lines I drew, the number of blanks. Because then we've got the nth term. Well, the nth term is like saying the number that sits on the blank. So in this case, if I was to look at term 4, for example, well, I'd go to the fourth blank, 1, 2, 3, 4. Well, then term 4 would be 11, because 11 is sort of what's sitting on that fourth blank. The 10th term in this case would be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And with our arithmetic sequences, we can figure out what number is sitting in that nth blank with the formula Tn is equal to T1 plus n minus 1 times D, where D is the common difference. Okay, so determine if this is an arithmetic sequence. If it is, what is the common difference? So again, most important thing you want to check for an arithmetic sequence is there a common difference? If there is, then it is an arithmetic sequence. If there isn't a common difference, then it's not an arithmetic sequence. So term 2 minus term 1, so we've got -6 subtract -10. Well, when we subtract negatives, we're adding the opposite, so this is 4. So if it's going to be an arithmetic sequence, our term 3 minus term 2 must also be equal to 4. So term 3, -2 minus -6, so again, add the opposite, that's 4. Okay, so those two have the same common difference, therefore it probably is an arithmetic sequence. So the first term, our T1, is -10. Term 2 is -6. And then we've got T10. Well, in this, we've got a relatively small number of numbers, I guess you could say. And so we could just keep adding, but if I had asked you for T977, well then you don't want to be counting 977 different numbers. So to figure out our 10th term, well, we could just continue our sequence, but we can also use the formula that I have in that top right corner. So we're going to look for T10 is equal to, our first term is -10 plus our n, so we're looking for the 10th term, minus 1 times our common difference of 4. So -10 plus, well, we've got 9 times 4 is equal to -10 plus 36, which is 26. And then we've got the general term. So our general term is an equation that represents any nth term in the sequence. So using that, we've got Tn is equal to our first term plus, well, we're going to leave n in there in order to represent every possible number times our common difference. And so our general term is we just simplify that expression. So Tn is equal to -10 plus, we're going to use our distributive property, 4n minus 4. So then our nth term is equal to -14 plus 4n. So if I wanted to ask you the 557th term, then you could just plug T557 is equal to -14 plus 4 times 557. So you can use it to find any term. 258. So first thing, do you want to check, is this an arithmetic sequence? We need to find a common difference. Well, looking at the numbers, to go from 2 to 5, that goes up by 3. To go from 5 to 8, that also goes up by 3. So yes, it's an arithmetic sequence. My common difference is 3. Determine the 40th term, our general term, and use the general term to find the 92nd term. So determine the 40th term using our formula. We've got T40 is equal to T1 plus n, well, it's the 40th term, minus 1 times your common difference. So crunch your numbers in your calculator, in your head, whatever your heart desires. That gives us 119. So then our general term, that's going to be the one that represents every possible nth number. So Tn is equal to our first term plus n minus 1 times our common difference. So again, we're going to distribute 2 plus 3n minus 3. Well, so Tn is equal to -1 plus 3n. It really doesn't matter what order you write it in. You could also write 3n minus 1. Those two expressions are the exact same thing. So use our general term to find the 92nd term. So T92 is equal to, I'm going to go 3 times 92 minus 1. Well, 3 times 92 minus 1 is -275. Nope, +275, classic. And to find the 500th term, T500 is equal to 3 times 500 minus 1. Well, that is 1,499. So check our understanding. So state whether the following sequence is arithmetic. If it is, determine the common difference, the 6th term and the 35th term, and determine the general form for each. So starting, we want to see if we can find a common pattern in how our numbers increase. So if we've got 9 to 14, well, that's 5. Then if we've got 14 to 19, well, that's also 5. 19 to 24, again, that's also 5. So we do have a common difference of 5. I'm going to find the general term first because then it's a lot easier to find our 6th term and our 35th term. So Tn is equal to our first term plus n minus 1 times our common difference. We're going to distribute. So then our general term is equal to 5n plus 4. So using that general term, now I can plug and find the 6th term. So T6 is going to be 5 times 6 plus 4. So that's going to be 30 plus 4, which is 34. If I wanted to find, I'm going to save the 35th term for the second one. I'll do that for B. Okay, so to figure out our common difference, well, again, if you can't look at it and figure out what it is right off the bat, you can always go term 2 minus term 1. So that's 3. And just to double check and make sure it is an arithmetic sequence, you can go term 3 minus term 2. We've got also 3. So therefore, our common difference is 3. To find our general term, so same thing, Tn is equal to our first term plus n minus 1 times the common difference, negative 8 plus 3n minus 3, so that's 3n minus 11. And so now to find our 35th term, T35 is equal to 3 times 35 minus 11. So 3 times 35 minus 11 is equal to 94. And then for example C, so again to check to see if we have a common difference, well, to go from 1 to 2, we would add 1, but to go from 2 to 4, we're going to add 2. So right off the bat, our increase is not equal. It's not the same. Therefore, this is not an arithmetic. Oof. Yep, that says arithmetic, not an arithmetic sequence. So given the first term and the common difference, determine the third term and the nth term given. So we've got T1 is equal to 4.5, D is equal to negative 1.2, find T3 and T14. First thing I'm going to say, if I give you decimals, your answer can be in decimals. But if I give you fractions, your answer must be in fractions. Okay, so our first term, let's start off, we're going to find T3 first. So T3, we're trying to figure out what that is equal to T1 plus our n. In this case, n always comes from with whatever term we're trying to find, minus 1 times your common difference. So in this case, let's do our order of operations. So 4.5 plus, this is 2 times negative 1.2. So we're going to have 4.5 minus 2.4. 4.5 minus 2.4 is 2.1. If I wanted to find term 14, I would just put 14 in for my n, same steps. For B, I'm going to find let's go term 21. I'll do that one this time. So we're given an answer or information in fractions. Our answer is going to stay in fractions. So T21 is equal to our first term plus the term we're looking for, so 21 minus 1 times our common difference, which is 1/2. So 3/4 plus, we've got 20 times 1/2. That actually works out to be a nice number, so 3/4 plus 10. So a couple ways you can look at fractions. So in this case, I've got 10 plus 3/4, which is going to be 10 and 3/4. From there, you can change that mixed fraction into an improper fraction. So again, multiply your denominator times whatever's up front and add the 3. So we're going to have 40 times 10 is, 40 times 10, classic. 4 times 10 is 40, plus 3 is 43/4. And we can't reduce that. Again, there's always the way you've done forever, which is find a common denominator. So 3/4 plus, I'm going to multiply this by 4/4, because our 10 is really over 1. I'm going to have 40/4, which is going to give us 43/4. So again, same answer, different ways to go about it. You can do whichever way your heart desires. So the general term of an arithmetic sequence is given. Find the 20th term. So again, a couple ways to go about this, like there usually is in math. You could either plug your n term in there and solve and just simplify. But in this case, it's also asking us to look for our general term, which means we kind of need to simplify. So 4 plus, we're going to distribute, -2/3 n plus 2/3. So 4 plus 2/3, again, different ways to look at fractions. We could say that's 4 and 2/3, or we could find common denominators. I'm going to go with the 4 and 2/3 method, so that's going to be 12 plus 2 is 14 over that same common denominator, minus 2/3n. Again, if you're looking at my fraction method and going, what are you doing? So to find a common denominator, it's going to be 12/3 plus 2/3, which is going to be 14/3. So I got the same number, different ways. So then to find our 20th term, we're going to plug our 20 into our n. So 14/3, I guess this is T20, is equal to 14/3 minus 2/3 times 20. Well, we can't really reduce our fraction, so 14/3 minus 40/3. 26. -26/3. So the general term of an arithmetic sequence is given. Find the 50th term. So we're going to plug 50 in for our n. So we're looking for T50, which is equal to 5 times 50 minus 1.5. So 250 minus 1.5 is 248.5. How many terms are in the sequence? So in this case, we are looking for, so if I'm asking you to find how many terms, that is your n. So Tn is equal to, this is our formula, T1 plus n minus 1 times your common difference. Well, we're looking for that last term. So what blank is that sitting in? Well, the number that's sitting in the blank is -26. Our first term is 10, plus we're looking for what number that is, times our common difference, which is, we're going down by 3 each time, so we are adding -3. And at this point, you can simplify. I'm going to go through 2 ways that you can do it, and you can do it whichever way you like. But the first way is the fact, I'm going to distribute. That's going to be the first way. So -26 is equal to 10 minus 3n plus 3. So combine our like terms, I'm going to end up with 13 minus 3n. If I subtract 13 from both sides, I have -39 is equal to -3n. Divide by -3, and that is 13. Another way you could do it, so I'm just going to rewrite my equation. N minus 1, -3. Well, the first step we could do is subtract 10 from both sides. So -36 is equal to n minus 1 times -3. Well, now if we want to get rid of that -3, we can divide both sides by -3. So that's going to reduce, and I'm going to have 12 is equal to n minus 1. And if I add 1 to both sides, I'm going to end up with 13 is equal to n. So again, there's lots of different ways that you can solve equations. Get good at the method that works for you. Okay, determine the number of terms in the following sequence. So same thing again, we're looking for our n. What I would probably do is, so start with finding your common difference. We know our T1 is 5. We need a common difference. We have our Tn, that is 3 over 8, so that's our last term. And we don't know what our n is, that's what we're trying to look for. Okay, so if you don't like subtracting, at this point, I would change it to a mixed fraction. So I'm going to have 32 plus 7 is 39 over 8. And if I want a common denominator, I'm going to multiply this by 8 over 8. So subtract 40 over 8. So our common difference is negative 1/8. So with our common difference, now I can figure out our Tn. Our n. 3/8 is equal to term 1 plus our n minus 1 times our common difference. So my first step would be I would subtract by 5 on both sides. So I'm going to get a common denominator, so negative 40 over 8 plus 3 over 8 is equal to, again, you could distribute that 1/8. I'm going to leave it just for funsies. So I've got negative 37 over 8 is equal to n minus 1 times negative 1/8. So two things that you could do at this point. Either you could divide both sides by negative 1/8, and maybe I'll do that just to show what it might look like. So divide both sides by negative 1/8. Well, if you're looking at that and going, oh my gosh, stacked fractions, remember what we really did is we have negative 37, I should go in my margins, negative 37 over 8 divided by negative 1/8. Well, when we divide fractions, we multiply by the reciprocal. So times negative 8 over 1. Well, that looks like a much more doable thing. So my 8s will reduce, and negative times a negative is a positive. So I actually just end up with positive 37. So positive 37 is equal to, those reduce to be 1, n minus 1. Add 1 to both sides, 38 is equal to n. So that means we have 38 terms in this sequence. All right, so determine the common difference and the first term of the following arithmetic sequence, then find the 50th term. I'm not going to find the 50th term. You should be able to do that by now. But in this case, we have two unknowns. And when we have two unknowns, that means we need two equations. So our first one, 50 is equal to, well, we don't know what our term 1 is. We know, plus, well, this one has 10 terms, and we don't know what our common difference is. So two unknowns, we need another equation. So we can use our T27, so 152 is equal to T1, again, we don't know it, plus, in this case, our n is 27, and we don't know what our common difference is. So either use your substitution or your elimination. That's what we're going to do. In this case, maybe I'll use substitution, just for fun. So that means we need to isolate one of our variables. T1 is probably the easier one to isolate on our left-hand side. I'm going to distribute my d, so then, well, I guess I don't need to distribute because 10 minus 1 is 9. 9 times d is 9d. So subtract T1 is equal to 50 minus 9d. Well, there, I know what T1 is equivalent to, so I'm going to substitute that into this equation. So 152 is equal to, well, T1 is really 50 minus 9d, I'm substituting that in for T1, plus 27 minus 1 is 26, times d is 26d. So subtract 50 from both sides, and I have 102 is equal to, well, 26 minus 9 is 17d. Divide both sides by 17. 102 divided by 17 is 6. So our common difference is 6. Well, so then to figure out my T1, the easiest place to plug it back into is our other equation. T1 is equal to 50 minus 9 times 6. So 50 minus 9 times 6 is 54. So therefore, our first term is -4. So what's the next term of the following arithmetic sequence? So what is D? We're looking for our common difference. Well, given two terms, remember to find our common difference, we always subtract term 2 from term 1. So 7 plus 6p minus our term 1, 3 plus 4p. Remember, you're subtracting that whole term, which means we're going to have to distribute that negative. So 7 plus 6p minus 3 minus 4p. So this was to find our common difference. So then our common difference for this term would be 6 minus 4 is 2p, 7 minus 3 is 4. So that's what our common difference is. So to figure out the next term, we would add that to the term before it. So 7 plus 6p plus 2p minus 4. So 6 plus 2 is 8p, 7 minus 4 is 3. So that's what our next term would be. Looking at our next example, we have 2r plus 5, and we're going to subtract r to figure out our common difference. So that leaves us with r plus 5. So r plus 5, this one you could do in your head. If you want to write it down, I mean same thing, 3r plus 10. Our next example, we have, I'm going to change to a different color, 2r minus s, and we're going to subtract s. So that leaves us with 2r minus 2s. So our original 2r minus s plus 2r minus 2s. So 2r plus 2r is 4r, negative s subtract 2 is negative 3s. And then for example D, well, it's term 2, which is b minus term 1. Well, we can't combine a's and b's, so that is going to be, that's like what our common difference is. So b plus b minus a is going to be 2b minus a. All right, so things you should be able to do. You should be able to identify if something is an arithmetic sequence, determine the common difference, the first term, the nth term of every sequence. Using the formula we have, find the nth term of an arithmetic sequence, as well as solve for numbers of terms and common differences. And then you should be able to use substitution or elimination to solve for D, T1, and N when any two terms are given.